Let's be real, in the world of illicit methamphetamine, the rulebook's been thrown out. What used to be a simple question of purity is now, frankly, a matter of survival. So today, we're going to walk through the science-backed, step-by-step methods you absolutely need to know to figure out what's real and what could be deadly. And that's really the heart of the problem, isn't it? In a market that has been completely transformed, a market with zero regulation, how can you possibly be certain about what you're actually holding? The old ways of checking how something looks, how it cracks back, how it feels, those are now dangerously, dangerously obsolete. And I can't stress this enough. The game has completely changed. Any assumptions about safety that might have worked, say, 5 or 10 years ago, they are totally unreliable now. The entire chemical landscape of the supply has shifted, and it's introduced these new lethal risks that are just invisible to the naked eye. So let's dive in. Let's take a look at this new chemical landscape and get a handle on exactly why the supply has become so much more dangerous. Okay, so the dangers have done a complete 180. It used to be mainly an economic risk, right? You were worried about getting ripped off, getting something cut with inert fillers that did nothing. Now the risks are life-threatening. We're talking about lethal contaminants like fentanyl, which can kill you with an amount smaller than a grain of salt. And these chemical imposters like N-iso, which are designed from the ground up to fool you. All right, so let's triage this. We've got to start with the most urgent threat first. Before you even think about purity or quality, you have to rule out the presence of something that can kill you on the spot. And that means we start with fentanyl. The thing about fentanyl is you can't see it. You can't smell it, you can't taste it. It's a ghost. So really, your only viable option for at-home testing is using fentanyl test strips, or FTS. These are just simple, brilliant little scientific tools that are sensitive enough to detect even microscopic amounts of fentanyl in a sample. Okay, now this is probably the most important and frankly kind of weird thing you need to remember about these strips. It feels backwards. A negative result, meaning you're all clear, no fentanyl detected, shows 2 lines. A positive result, meaning danger, fentanyl is detected, shows only 1 line. You have to burn this into your brain. Any second line, I don't care how faint it is, means the test is negative. 1 line is a warning. 2 lines is the all clear. But hold on, and this part could literally save your life. You cannot just use the standard instructions that come in the box with these strips when you're testing meth. If you do, you could get a dangerously wrong result. So why on earth is the protocol different? Well, it comes down to this thing called methamphetamine interference, which can basically trick the test into giving you a false positive. To stop that from happening, you have to use a much higher water dilution. We're not talking about the 1 teaspoon of water in the instructions. We're talking 1/4 to 1/2 a cup of water. It's a super simple change, but it is absolutely the key to getting a result you can actually trust. Okay, so once you've ruled out the immediate lethal threat, it's time to tackle the next big problem, the deceptive one. And the question is this stuff even methamphetamine at all? This is where we have to hunt for the chemical imposters. The main bad guy here is a substance called N-isopropyl benzylamine, or N-iso for short. And it is a true chemical doppelganger. It's been engineered to look and feel exactly like meth, right down to forming those big, beautiful, clear crystals. This means just looking at it is completely useless. You have to turn to chemical testing. So your first line defense here is a marquee reagent test. It's super simple. It's just a color change test. You add a single drop, and if your sample flashes orange to brown, that's a positive sign that methamphetamine is present. If you get no reaction at all, or maybe just a faint yellow, well, you're almost certainly looking at N-iso instead. But, and this is a big but, you have to understand what this test can't tell you. A positive Marquise test only tells you that some meth is in the mix. It doesn't tell you if it's been cut to hell with N-iso. And the Simon's test, which a lot of people try to use, is even worse. It turns blue for both of them, which makes it totally useless for telling them apart. So when the reagents just aren't enough, we need a definitive tiebreaker. And for that, we have to turn to some basic physics. We're going to look at a fundamental property that simply cannot be faked. It's melting point. Okay. Here's our first hard number. This is science, not a suggestion. Pure methamphetamine hydrochloride has a very specific melting point. By the time that sample hits 175 degrees Celsius, it must be completely liquid. That's not a guideline, it's a physical law. Now let's look at the imposter, N-iso.
its melting point is way higher, up around 192 degrees Celsius. That difference, that nearly 20-degree gap, that is the key weakness that we can exploit to definitively identify it, even if it's mixed in.
And the best part? You don't need a fancy lab to do this. You can use what's called the oil bath method. You just slowly heat a tiny sample in some cooking oil while watching a high-temp thermometer right next to it. If you see any solid crystals left after the temperature blows past 175 Celsius, you've got your answer. You have confirmed the presence of N-iso.
Okay, before we wrap this all up into a nice little package, we have to talk about some of the myths out there. Because some of the stuff you hear, some of these popular home tests, are not just wrong, they're actually dangerous. You've probably heard of this one. It's the most famous or infamous of the bunch, the bleach test. The idea is you drop a shard into bleach and watch for it to dance around and leave an oily slick. It gets shared all over the place, but from a scientific standpoint, it's just deeply, deeply flawed. So let's break down exactly why this test is a total failure. First, N-iso can react in a very similar way, so it's not a reliable way to tell them apart. But way more important than that, the chemical reaction produces toxic chloramine gas. You're literally creating a poison cloud in your room. So it's an unreliable test that is also actively hazardous to your health. Just don't do it. All right, so let's toss out the myths and get down to business. Let's pull all this science together into one clear, easy-to-follow protocol. This is your gold standard for safety. It all boils down to a simple, 3-step safety check. Step 1, always, you screen for the lethal stuff first with a fentanyl test strip using that correct high-dilution method. Step 2, you verify what it is with a Marquis reagent test. And step 3, the final definitive confirmation, you use the melting point test to rule out that N-iso imposter for good. Look, if you follow these 3 steps, you're getting the highest level of certainty you possibly can outside of sending a sample to a professional lab. In the market as it is today, this kind of knowledge isn't just power, it's the absolute best defense you have. The only question left is, are you prepared to use it?